Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary tree, that is nothing but populating next right pointers in each node. So without wasting time, let's try to understand it. Okay, in this question we are provided with a complete binary tree. Let me create a complete binary tree. We already know what are the properties of a complete binary tree. Let me highlight them again. Okay, so in a complete binary tree, all the leaf nodes are resides at the same level. Okay, and one more thing about the complete binary tree is that means unless and until unless and until there will be no left child node will present for a particular parent, you can't make means for each parent the left and both the left and right, both the children exist for a particular parent. Here you can see all the parent nodes have both the left and the right children. Okay, and all the leaf nodes are present at the particular level and are at the same level. Okay, now let's try to understand the question. That is a problem statement of this question. Okay, so in this question what we need to do is that we are provided with a complete binary tree, and each node of this complete binary tree have some property, some extra property assigned to them. That is, each node, we already know each node have some properties with that is the value, that is the left, which indicates the left child, the right, that indicates the right child. And here also, like in this question, there is one extra property, that is the next. What this next does, we will discuss it soon. Okay, the first thing is that for each of these nodes the next property is null. So this property is null for each of these nodes. What we need to do in this question is that we need to update this next property in such a way that this node start pointing to this node start pointing to this. These links get updated in such a way like this. Okay, like this, and these links will start pointing to the null. Okay, will start pointing to the null. So we need to update this next pointer for each node in this way. So I hope you get it. What we need to do in this question, you are provided with the complete binary tree, and here each node has some extra property, that is the next property, and you need to update this next property in such a way that each node's next get updated with its sibling. Okay, neighboring sibling. So it's my request you pause this video right now, try to solve this question by yourself, and then watch the solution part. So I am assuming you have tried it by yourself. Let's try to understand the approach of this question. Okay, so so let me erase it. Let me create the original tree. So we already know that we are provided with this tree with some features. Now what I'll do at first, I will have a faith, like each question we will, so like most of the questions we will solve with a faith. This question also I'm going to solve with a faith. I'm assuming that these three levels, this level work has already been done. These links have already been updated. Okay, now what I'm going to do, like I'm assuming that these links have already been created up, and we need to create these links only. Okay, we need to create these links only. Now what I'll do, I have a pointer that is pointing here, and I am named it as n. Okay, I have named it as n. Now what I'll do, I just need to update its left and the right children in such a way that their next node get updated. So what I'll do, I'll update its n's left next with the n's nth right. I will update its nth left next with the nth right. Just try to understand why I've written this code. Okay, just try to understand. I according to my requirement of the question, okay, according to the requirement of this question, I need to update the nth left children with next to point to the nth right. Okay, I need to update this link in such a way that nth left next start pointing to this particular node, and this particular node is nothing but nth right. So I have written this case. Okay, so I can say that this this link is suitable enough to update my left children, but each node have two children, left children and the right children, and I have only updated the left children node. So let's update its right children node. So update just to update the right children node, I will write something like this: n's right next. N's right next, I will update it with something like this: n's right next with n's next left. Now you might be thinking that what I have written here. So as we have already discussed that we have updated the n's left children, now let's try to understand how we updated its n's right children. So its n's right children is nothing but this node, and we need, and this node next can only be updated when it start pointing to its neighboring sibling. This node need to point this neighboring sibling. Okay, so now what I'll do, what I have written here, and according to my statement, how it works, like I have written ans right next. That is, I am updating its next pointer in such a way that it start pointing to the n next. Ans next means the current node next left. That is this node. I am updating it in such a way that its next start pointing here. Okay, so I am updating this link. Now I updated the ans left and the next pointer. Now what I'll do, I will update my next to point to the ans equals to ans dot next to point its next pointer. Okay, so I'm just doing nothing. I'm just updating my end pointer so that it start pointing to this next node, and the moment it get updated and start pointing to the next node, what I'll do, the moment start pointing here, now I can update it this next node left and children node, so that these left and children next can also be updated and start pointing to the correct position. Now again, what I'll do, I will perform the same type of operation for this left and right children also. This current node next, I will left next, I will update it with the ans right, so this node get established. Similarly again, ans right next get ans right next get updated with the ans left next. That is, this node get updated with this. Why I am confident enough just because I believe that the nodes, that is these nodes, links are already created. And earlier it was my assumption, but but in the real examples I need to update them. Okay, so now what I'll do, I'll take one more pointer. That is, I'm taking the black pointer. Okay, I'm assuming it as a black pointer, and I created a black pointer, and what this black pointer does, it performs the traversal. Okay, traversal of the boundary traversal. I can say it traverses only the left boundary or this boundary. Now what this left traversal, what this black pointer does, the moment it reaches to any of the level, it updates my ans pointer to that level, so that this ans will perform a level order traversal to that particular level. And the moment this ans is actually updating the level order traversal, what this ans is actually doing, it is actually updating the nodes of the n+1 level. There may be possibility you are not getting my point. Let me explain you once again. Okay, let me explain you once again. So let me take it somewhere here. These were the important conditions. Okay, and this was my tree. Let me remove something from this tree. Yeah, and let me remove this black. Yeah, so what is going on according to my intuition? I have created a black pointer, and what this black pointer does, we have already discussed it. It performs a boundary level traversal and a particular boundary level traversal. That is only the left boundary traversal. It performs this left boundary traversal, and each moment it reaches to any of the boundary point, that is new level. The moment it reaches to this point, it updates. It creates a new pointer, that is this end pointer. Why this end pointer is used? Just because this end pointer performs the level order traversal. Okay, that particular level order traversal, and while it is performing a level order traversal, what it is doing, with the help of the nodes of that particular level, it updates the links of the next link of the n+1 level. Okay, means while okay, so while this end pointer is iterating over this level, it is actually updating the next link of the n+1, that is this level. Similarly, while n start iterating over this level, it start updating the links of this n+1 level. Similarly here also, while n start iterating over this level, it start updating the links of this n+1 level. So so how this n should be able to reach to each next level, black pointer will help the n to reach to the each next level. Okay, now the another boundary condition. Okay, the another boundary condition, the moment n reaches to the null, okay, means the moment n dot next become equal to the null. This is again one of the important boundary condition. The moment we reaches to here, the moment we reaches to the here. Okay, the moment we reach here, we are not allowed to perform this operation, because if we perform this, we get a null pointer exception. Means we are just trying to access that pointer which are actually not we are actually trying to access that memory location which are actually not available or not allocated to us. Okay, so the moment we reach to this point, we are not allowed to perform this. So before updating this, we need to check whether n.next is a null or not. So these are the basic condition which we need to perform here. So these are the two conditions which update the links of it, and each time after performing the link, we need to update the next to move to its to move to its next level, to move to the next node of a particular level. And while a next completed n node completed iteration over a particular level, we need to move nth node to move to the next node, to the next level, that is nothing but the n+1 level. And which node helps the n node to move to the n+1 level? That is nothing but this black node. Okay, so I hope you get the intuition of this question. So now what we are going to do, we will move on to the pep coding portal, and there we write the code of it. Okay, so this is the pep coding portal. Let's try to write the code here, and we need to complete this connect method. So let's complete it. At first we need to create a black node. So renode black goes to root. Okay, what this black node does, actually, it iterates throughout over the boundary. Okay, it iterates over the left node, and it helps me to get each level at each moment of time. Okay, now moving forward, while black is not equals to null, black is not equals to null, and black dot left is not equals to null. If such a case arises, what I need to do, I just need to create a new node, that is, and update it with a black. And what this tree node and does, it helps to iterate over throughout the level, and it helps me to iterate over each level. Okay, so each time I move the black, I update the tree node and create the new node, and this and will iterate over the each level. Now let me again create one more loop, that is while true and dot left dot next, actually, and dot left and dot right. I'm updating ends left next with the ends right. Okay, similarly again I will check a condition. If n dot next equals to null, I'll just break the loop and just come out of the loop. Okay, otherwise what I will do, otherwise I will update the n right next with n right next with and right next with and next left. Okay, one more thing, n equals to n dot next. The moment I come out of the loop, what I need to do, I need to update the black pointer. And where do I need to update it? I will update here. I will update it to move it to the, to point it to the left node. Okay, so that it will iterate completely throughout the left nodes. Now at last what I need to do, I just need to return the root. So that's all for the code. Let's try to run it, and here it get accepted. So that's all for this video. I hope you like the content of this video. I hope you get the intuition of this question. So if you like the content and the explanation of this video, please hit the like button, share it with your friends, and subscribe to our YouTube channel. So let's meet in the next video. Till then, stay safe, stay healthy, and keep learning.